For the past year, I've been working on an update to the Snow, Water, Ice, and Permafrost in the Arctic SWIPA report that came out in 2011. I'm working on a 5-year update to that, just the chapter on land ice. There's other chapters about Arctic atmosphere and ocean sea ice, etc. And so this past year, I've been reading some 250 scientific publications that have emerged just in the last 5 years. And they have brought our knowledge forward in such an impressive way that what I'm arguing that we have now is the field of glaciology has finally come of age. The field is maturing to the extent that I'm arguing that we have now a unified theory in glaciology. And that's because of the proliferation of observations from satellites, GPS, oceans, and sophisticated satellite remote sensing, airborne remote sensing. So lots of data has been flooding into this field, especially in the last 5 years. I remember 10 years ago, the argument was the Arctic is a data void. That's more like 20 years ago. So in the last 20 years, I've observed this flood of information come into the field. And today, I having made this review, I think we're at a proud moment in glaciology. And the theme of that is interaction. We have ice-atmosphere interactions and ice-ocean interactions. And the fundamental laws of motion in glaciology, if you will, there's two ways that ice moves. And that's by internal deformation, it's flowing under its own weight, and basal sliding, whether that's lubricated bed by water or the deformation of the subglacial environment, the subglacial till. Those processes, internal deformation and basal sliding, are all affected by surface atmosphere interactions. That's meltwater making its way through, heating the ice internally, lubricating the bed. That's a direct connection between the large increase in surface melting on land ice and its flow through the ice, warming it internally. Warmer ice is softer, it flows faster, and then the basal lubrication, the flooding of the basal environment that's thawing the bed, lubricating it, pressurizing it. Despite some self-regulation of that basal water pressurization, it loses its power through the melt season. But it comes back the next year as the subglacial network collapses, and that cycle is repeated each year. That's the atmosphere-surface interaction. And then you follow the water down into where it ejects into the ocean environment, and that drives a heat exchange between a arguably warming ocean and warm water layers that it forces an exchange that undercuts glacier fronts, promotes calving. The calving of icebergs is an immediate loss of internal flow resistance, so you get glacier acceleration due to calving, due to undercutting of the glacier front. There's also the forced heat exchange is eroding the grounding line, where the water rushes out into the marine environment at these underwater glacier cliffs. That water is eroding ice right at the grounding line, where the ice would begin to float otherwise, or where the ice is pushing out. And that's a critical place to remove flow resistance. So that's the connection from the ice-ocean interaction that's driven by the water that's forced its way through this system. All of that observations are showing us is unified. We see the fundamental motions of ice, the internal deformation, the basal sliding, affected by atmospheric heating that increases surface melting, again drives that water through, which drives a heat exchange with a warming ocean. Ice, atmosphere, ocean interactions have all come together in an observationally rich story that the last 5 years of 250 plus publications on the topic is that's the picture that it's painting. And so, despite the tedious work of trying to make sense and to read more than 200 scientific articles, this snow, water, ice, and permafrost in the Arctic SWIPA update has been very useful to try to take to form a helicopter view of the field. And so I think that's the benefit of this hard work. And now that the final draft of this SWIPA report is about to be delivered, and this is after two kind of pre-final draft reviews, external reviews, and also the input of about 15 contributing authors from Arctic nations and experts around the Arctic to try to create balance geographically, but also in time scale. We're at a point where we can produce the next SWIPA report, which will be the update to this monumental first SWIPA report. This IPCC-like assessment report just for the Arctic was actually preceded by the ACIA report. It's documenting, it's a testament to the profound growth in our knowledge, the proliferation of observations, and I think it does deliver this message that for land ice glaciology, we have the emergence of a mature field. We have the emergence of what we could call a unified theory, the unification coming from observations that support the basic ice flow principles, internal deformation and basal sliding, and the climate connection that we have from our observations. So I hope that this kind of the satisfaction that I'm starting to feel from this is somehow rubs off, and that we now know more. But there's actually two critical gaps that emerged from this review. We know that land ice serves as a very useful indicator of climate change. A glacier retreats, snow line goes up higher and higher each year. The bare ice area gets larger every year. The melt onset happens earlier, increasing rainfall. That's the utility of ice is to indicate change. Then there's the impacts, and we've become focused on the critical, but I would argue a medium to long-term issue of sea level rise. Definitely a major problem starting now, but really starting to hurt, more than decades from now. That's really when you start to flood coastlines. There are immediate two other impacts that we don't know much about. Number one is all this increasing water that's moving through these glaciers, making it to the bed, is increasing sedimentation. So all of the rock material at the bottom of these glaciers that the glaciers are grinding up, there's a lot more of that material, it seems, being pushed out into the marine environment. That's nutrients for fisheries. There's like 3 or 4 publications, that's it, on the increase in sedimentation and the nutrient impacts. Think about that doubling of freshwater output from glaciers in the last 50 years. Effectively, I guess, doubling the amount of nutrient supply into the oceans. That might have an increasing productivity effect on fisheries, for example. that literature is not well defined. The other impact that only has a few observationally based studies is about the disruption of all of this additional fresh water to ocean thermohaline circulation. It appears that the increasing meltwater supply is like slowing down the Gulf Stream. But of course, it's much more complicated than that. And the question of how much water can recirculate in the North Atlantic and elsewhere, and what effect that has on the weather that we're experiencing, we think that it does have that effect. But there's only a handful of publications that directly deal with that using observations. There's many modeling studies, but the thing is with the observations that we just don't have the length of records that we need to separate internal variability from long-term trends, because like the North Atlantic appears to have this multi-decadal oscillation, and with a 20-year high quality record, we don't know how much of the observed trend is due to riding up and down an oscillation versus what would probably be that is superimposed on this kind of hockey stick of increasing meltwater supply, which is pretty obviously happening in the Arctic. So this SWIPA update to this 450-page document. It adds a tremendous amount of detail about ice, atmosphere, ocean interactions. I think we can now look at this system as a holistic, interacting system, and we've got lots of details about why and what's going on. That is what I think the main deliverable of the SWIPA update is. And then the critical gaps are what are the changing in nutrient supply into the oceans due to changing land ice runoff into the ocean, and then the impacts on the changing freshwater flux, the disruption of the thermohaline circulation. The document does capture a long list of observational gaps in future work, and something like 4 pages of single-space bullets about what's new. So that should be coming out in the year 2016 or 2017.